Hey, in this video, we're going to talk about trig modeling, particularly those type of questions where they describe waves, okay? High tide, low tide. And we have to just read the situation and try our best to model, right? Assuming, right, this is going to follow a periodic sine or cosine function. Let's do this by taking a look at an example together. Okay, here it is. So during the first 12-hour period, the tides in one area of Bay of Fundy causes water level to rise 6 meters above average sea level and then fall below 6 meters as well. The depth of the water at low tide is 2 meters. Okay, so that's describing low tide is 2 meters. Okay, it will fall 2 meters below sea level. So sea level, I guess, will be 2 plus 6, right? Which is 8. Plus 6 again is going to be 14. Okay. Is this right? I just want to double check. And the fall 6 meters below sea level. Okay, so this is a depth, okay? All right, so suppose that the water is at average sea level at midnight. So this is the average sea level, and the tide is coming in. So tide is coming, it's gonna rise. Draw a graph that shows the height of the tide over the 24 period. So it's gonna go up, go down, and come to the middle. This is 24 hours. Okay. All right. Part B, determine the equation that represents. Okay, so now it's time to do some work here. So the height, or the depth, I guess we should say the depth. The depth is going to be, amplitude is 6, right? 6. It's a sine curve with a K, no phase shift, and there's a vertical shift of 8. Now, the period is 24 hours. We know that 360 degrees over K is 24 hours then. So K must be 360 divided by 24. Let's divide top and bottom by 6. 60, and I think we get 30, 15. So this is it. 15t plus 8. Okay, so that's a sine function. As a cosine function, everything stays the same except for there's going to be a shift this way. Okay, how do we know what that shift is? Well, that's exactly quarter of the period, right? So 26 divided by 4 is 6 hours. So we just have to change to cosine, same period, t minus 6 to shift it, right? We need to shift it, and then we get the cosine graph. Okay, part C, suppose that the water at average sea level is at sea level at 3 a.m. and the tide is coming in. Write an equation that represents this new situation. Okay, so not here at 3 a.m. At 3 a.m., suppose that we start from here. The only difference will be is the graph shifted, right? Shifted. So everything stays the same. We just have to shift it to the right by 3 hours. We subtract 3. Okay, so that versus that. That's it. And typically in a question like this, they ask you other stuff, like what is then, at what time, was the depth like 10? Right, other things like that, but we'll stop here and we'll cover some more questions together later with those type of problems. So that's it for this one. I'll see you in the next.